So we'll move next to Kenza, who worked on the green glass recycling. So Kenza, floor is yours.
All right. Hello, everybody. My name is Kenza Nekmouche. I hope everyone's doing okay this morning. I'm here to talk to you about the challenges associated to the valorization of end-of-life green glass bottles in Quebec. It is a pretty specific topic, but I hope you guys will be interested by it. So to talk a little bit more about me, I am a third-year chemical engineering student at Polytechnique Montréal. I'm 22 years old. What I care about the most would be mental health, environment, and music. I'm half French and half Moroccan, and I've lived in Morocco my whole life until I came here 4 years ago to study. I'm very grateful for this opportunity as it opened the way for me to realize that I can be, even to a little tiny scale, a little bit helpful to the world. So I'm very happy about that. Uh, sorry. So the challenge itself is kind of easy to understand. The colored glass recycling in Canada is considered a real issue because there is an unknown quantity of colored glass that goes to landfill. And it is also very difficult to find exact and correct numbers about how many, like the quantity that goes to landfill in literature. So also there's only a few furnaces that treat only white glass in Quebec, such as Owen Illinois Glass. And this is an issue, as you will understand later on. And the quantity of colored glass does not justify creating a new furnace that would treat 300 tons of glass a day. Because the population in Quebec is not big enough for us to consume that quantity of glass per day. And so some brands want to make a change and be an eco-responsible consumer. Although there are projects to improve glass recycling that are starting to emerge, such as the development of a deposit by the SAQ, we were very interested in this topic and we wanted to understand a little bit more about the issue itself. So the plan of the presentation will be that first we wanted to talk about the primary glass production and how glass itself is made. So we wanted to understand how it's made, why it is made that way, and the energy requirement and its CO2 emissions. So this is important to understand the process to, again, quantify the CO2 emissions and the energy requirements, and in the end, to quantify the impact of adding recycled glass to the process. We also made a life cycle assessment of green glass bottles, typical ones, to quantify and identify the different impacts of the product on the environment. And lastly, we will talk about what we should do next to improve green glass circularity. So, typical soda glass is made out of these components that you see here. We used Fact Sage also to determine the reagents that you find here. It is mostly composed out of silica, which is sand, and it's we also add sodium oxide and sodium carbonate to lower the melting point of silica, which makes the production of glass easier. So the process itself works this way. We add raw materials that you see right there in this figure. We add them into a furnace, we melt them, and then it goes to forming, annealing, it all gets inspected, and then we go to packing and obtain a glass bottle. So also, there's a definition you need to know before I keep going with my presentation. Glass collets are broken recycled glass in pieces. So it is sometimes added into the mix, as it is better to add recycled material to the whole process, and it allows the process to radiate less CO2 emissions. So here you have two figures that basically show the effect of the size of a furnace on the primary energy needed, which in the end shows us the efficiency of the furnace. And here in figure 4.1, you can see the specific energy consumption depending on the quantity of cullets added. So the efficiency of a furnace depends on the amount of glass produced per day. So as you can see in figure 4.2, it is impossible for a small furnace to have a high efficiency as it needs more primary energy for less glass production per day. Also, in figure 4.1, you can understand that the more you add collets, the less energy is needed, as there is less decomposition of the carbonates that react. Also, even if 100% of glass collets are used, there still will be CO2 emissions because there will still be energy that is needed to the process. You have to know also that a standard glass-making furnace produces 300 tons of glass per day, and it is fueled by natural gas such as CH4, so methane. To do our calculations, we used FactSage, obviously. We used FactSage to calculate the CO2 emissions related to the glass production. So we basically used FactSage to calculate the emissions related to the decomposition of the carbonates, because when there is carbonates, they will decompose and radiate CO2. And also, that column right here of CO2 emissions related to the extraction of the raw materials were calculated with a software that we used to do a life cycle assessment that was called OpenLCA. Also, it is important to remember that all of these results are theoretical, and that was our study with Jean-Philippe. We also used FactSage to calculate the theoretical values surrounding the energy requirements. You have to note that there are two main energy contributions. There is the thermal decomposition and there's melting of the raw materials. So the total energy requirement that we calculated was 2.977 megajoule per kilogram of glass. And the emissions related to the combustion of natural glass were around 0.16 kilogram. The total energy requirement is around 3,000 megajoule per ton, which is very coherent with the graph that we previously presented, and it equals to around 50 to 60% of efficiency. So a little bit more about the life cycle assessment that we made. You have to note that a life cycle assessment has multiple impact categories. The first would be climate change, that is counted with CO2 kilograms equivalent. And the life cycle assessment that we made first studied the glass production and its impact on the environment, glass waste, and glass treatment and end of life. The goal here was to analyze the environmental impacts of glass production and its end-of-life treatment, and the functional unit that we used was the use of a typical green glass bottle of 0.75 liters. Here is the study that we made with Jean-Philippe. So to show you a little bit more how we did that, we started with the functional unit, which was the consumption of a green glass bottle. And we linked that to the transportation, the filled bottle production. So to understand the impact of a whole bottle, you have to consider every tiny detail that composes it. So you have to understand the impacts of the metallic film production, the green glass production, the label production. And we use the database that's called EcoInvent to have these numbers around the raw materials and energy. We also excluded from the study the alcohol production that is filling usually the bottles and the bottling process. So we made three basic scenarios. The first one would be a typical glass made out of 50% of glass collets. The second, 90%, and the third would be a perfect scenario where we use 100% of glass collets. You have to note that the more collets you add, the more CO2 emissions are reduced. Although even though we have 100% of glass collets, you still have CO2 emissions. So we have a total for a typical glass of 0.43 kilogram of CO2 per kilogram of glass. What does that mean exactly? It means that with 200 millions of bottles sold every year by the SAQ and 4 tons of CO2 emissions per year per car, this would be equivalent to 18,185 cars in a year, to show you a little bit more in reality what that means. So what do we have to do next? We know that glass has an infinite capacity of recycling as it doesn't lose its properties when melted. Also, there's only a few furnaces in Quebec that only treat white glass. And you have to know also that changing the color of the glass while melting can take up to 24 hours. So that's why you cannot mix white glass with green glass. The challenge today for glass makers would be to electrify the process because currently we only use 10% of electricity in the energy mix, because you have to know that melting glass is conductive, whereas normal glass is not, but that's why you don't add more electricity for now. And so today, new technologies are considered, such as using a green hydrogen furnace, but this would probably have a possible high cost. Another challenge would be to understand how the new flame would work, because it would be different with one of natural gas. So this is a very interesting project in perspective, and I hope you guys liked my presentation. Sorry for mumbling sometimes, but I hope you guys enjoyed.
Thank you so much, Kenza. No, everything's fine, and we enjoyed it. I must say that it's fun to see that the new student, they have a high quality English speaking, so it's pretty impressive. Okay, so again, we're a little bit late on time, so I will move on to the next presenter.